given that the integral between 0 and theta of 2 sine squared x dx is equal to 1/12 of pi minus 3, show that theta is equal to pi over 12 minus a quarter plus a half of sine 2 theta. And then Jane uses fixed point iteration with theta 0 being equal to 0.26 to find the value of theta. The table below shows some of our values, and we've got to calculate the two missing ones, which are here. Okay. So, first of all, we're going to have to work out the integral. So, the integral from 2 sine squared x dx. To do a sine squared, you have to use cos 2x is equal to 1 minus 2 sine squared x, and then rearrange that as sine squared x is a half of 1 minus cos 2x. So we're going to have from 0 to theta of 2 times 1 half of 1 minus cos 2x. So we substitute that in there instead of sine 2x. We still need the 2 outside because this is 2 sine squared theta. It's still equal to 1/12 for pi minus 3. Now the 2's conveniently cancel out. Then if we integrate 1 with respect to x, we're going to get x. And then if we integrate cos 2x, we would try sine 2x. But when we differentiate that, we're going to get an extra 2 in front. So we need to put a half in front. And the limits are from 0 to theta. And it's now equal to 1/12 times pi, which is pi over 12, minus 1/4. So that will give me theta minus a half sine 2x. When I put theta in, and when I put 0 in, conveniently I get nothing. And it's still equal to pi over 12 minus a quarter. Making theta the subject, we get theta is pi over 12 minus a quarter plus a half of sine 2 theta as required. Right, so using that, with x0 being equal to 0.26, we've got to calculate the next two iterations. Okay, to do that we use our graphics calculator. So first of all, make sure your calculator, so put it in mode 1. Okay, and make sure your calculator is in radian mode. Let's just delete everything that's there already. Okay, it is in radian mode. Okay, so first thing we need to put in is that 0.26. So we put in the first value and then press enter. Okay, and then what we need to do is we will enter pi over 12. So fraction button, shift pi, the pi didn't, shift. Okay, we're having a little bit of problem with the mouse on my computer. We'll try again. Shift, pi, then we need to go down, 12, move the cursor along, minus a quarter, so minus fraction button again, 1, and then go down, and we'll get a quarter, move it along, okay, and then plus fraction button again, 1 over 2 of the sine, brackets, is 2x, so we 2 times the answer, 2 times shift answer, and close it off. Okay, if we press enter, because we'll do 2 times 0.26 first of all. So if we press that, we get the first iteration, which we can write down. And then if we press it again, we get the next iteration. And then we'll get the other iterations, which are in the table. And if we carry on, we will get it like to converge on, interestingly. It's very slow in converging, but it looks like it's going to converge on 0.262 to 3 significant figures. Okay, so having done that on the calculator, we're only asked to write down theta 1 and theta 2 in this case. So writing this down, make sure the calculator is in radian mode. So you're going to get the first value and then the second value, which are the 2 values missing in the table. Okay, so it's been a video to show you how to find the upper limit of an integral and involving a little bit of fixed point iteration. I hope you've understood, and I thank you very much for watching.